Hi. All right. So we're on 4.1, day 1, extrema on a closed interval. So we're going to learn what these words represent today. Okay. So global or absolute extreme values are what we're going to be looking at today. And we can have an absolute maximum or we can have an absolute minimum. So I'm going to start by showing you what that looks like on the graph. So let's cross out example 1 because we're not doing that one. And let's draw a picture of a graph. So we'll go, oops, I don't want an arrow. I want an endpoint. Endpoint there, endpoint there. Because a closed interval means that it's from one end to another. It ends, okay? So it's just usually a piece of a graph. So when we're looking for the absolute maximum, we are looking for the highest high in a graph. Well, up here, this endpoint would be the highest high. Highest high is called the absolute maximum. Let's call it absolute max. Okay? So then on the flip side, the lowest low is called the absolute minimum. So our lowest point on this graph would be the other endpoint, the lowest low, and we call that the absolute minimum. So let's call it absolute min, okay? So when I'm talking about the absolute max and the absolute min, I'm talking about a y value over the domain, over the x values, okay? And the absolute max and absolute min isn't always going to be the endpoints. There could be a peak somewhere in the middle or over to the left end or right end that comes up before the endpoints that reaches that highest high or that lowest low. And so we're going to be looking for those and figure out how to find them. Okay, that's what we're looking for. We're looking for the extrema. And the extrema are basically the highs and lows of the graph. Okay, but when we want to find the absolute maximum or absolute minimum, we're looking for the highest high or the lowest low. Okay, so let's take a look at an example. Example 2. And it says, find the absolute extrema for the given domains. Okay, so they gave us a domain from negative infinity to positive infinity. That means that this is forever. Forever. Okay, and we know what y equals x squared looks like. That's a parabola. So I'm going to show you how to do it graphically, and then we're going to learn how to do it algebraically, so by hand. We all are also going to be using our graphing calculators, so make sure you get those handy. I hope mine lasts because I haven't charged mine in probably a month and the battery is like dying. It is barely there. Okay, so x squared, we know what it looks like. We know that it is the parent parabola function, okay? And we need to find the absolute extrema, so the absolute max and the absolute min. When it says extrema, it's talking about both absolutes, either the max and the min, okay? So the highest high, well, these arrows are going up to infinity. So that means it's never gonna end. It's gonna keep going on forever. So it doesn't have a highest high. So the absolute max equals, there is none. The absolute min, well, the lowest point we're going to is right where that vertex is, and when we're looking for the min, max or min, we're looking at the y values. So that lowest y value is a 0. So the absolute min is 0. But what x value is that at? So it's at an x value that is also 0 in that case, because that's the point when x is 0, y is 0, 0, 0. All right, so there's my absolute max and absolute min. Those are my absolute extrema for that graph. Lucas, can you stop whistling, please? All right, let's look at letter B. y equals x squared, so it's still the parent function, f of x equals x squared, but this time we're on a closed interval. It's closed because we have the square brackets. So it's going to start at 0, x equals 0, and it's going to end at x equals 2. It has a start and a finish. So let's draw our graph. We have to be a little more specific on this graph this time. And okay, so I know that I could plug in a 0. If I plug in a 0 for x, I get 0. If I plug in a 2 for x, 2 to the second power is 4. So I'm going to get the point 2, 4. So I know that this is a parabola, so I know it's going to curve up, but I'm only seeing a piece of that parabola, okay? So what is the absolute max and the absolute min? Well, the highest high ends up being that second endpoint, when x is 2. And so that absolute max is at a value of 4. So we have an absolute max, and that is at a y value of 4, and that is at an x value of 2. So absolute max is 4 at x equals 2. I'm using the at symbol. And then the absolute min, well, the lowest low is the other endpoint. The lowest it's going is 0 at an x value of 0. So those are my absolute extrema. The highest high and the lowest low. Letter C, y equals x squared. This time the interval is half open, half closed. It's open on 0, so that means we can't include 0 as an endpoint, and it's closed on the 2. So what does that look like? What does that change? Well, let's see. At 0, we know it's the point 0, 0, right? When we plug in a 0, it's going to be 0. But because it's an open interval there, we have to put an open point, okay? And then at 2, it's closed, so we have the exact point 2, 4, okay? So it's still the same graph, except it's an open point there. So let's see how that changes what our absolute max and min are going to be now. So we're going to have an absolute max, and that is going to be at the same thing, 4. So 4 at x equals 2. And then the absolute min, well, we can't include the 0. So since we can always get closer and closer and closer to 0 without touching 0, it doesn't have an absolute minimum. So, because you can keep dividing a number and dividing a number and dividing a number. So you could keep getting smaller and smaller and smaller by dividing, but it's still never going to equal 0. Because we're not multiplying by 0, and we know we can't divide by 0. So there is no minimum. So when we can't include, when it's an open interval on one side, we can't include that point, so then it won't have a max or a min. In this case, a min. All right, let's look at letter D. Still the same function, but this time the interval is open. What does that mean? Well, that means we have an open endpoint at 0, 0, and an open endpoint at 2, 4. It's still the same graph, it's still a parabola, but now because that highest high is approaching an open point that I can't equal an x value of 2, can't equal an x value of 0, then that means that it does not have either. It doesn't have a max or a min. So it has no absolute extrema, so there's none. Okay. I hope you guys are with me so far. All right, so that leads me to the extreme value theorem. This one is the big kahuna, the big deal of this unit, okay? If f is continuous, everyone say continuous, on a closed interval, AB, so it's got to be a closed interval, then f has both, everyone say both, a maximum and a minimum value on that interval. So as long as we are dealing with a closed interval and the function is continuous, it will have a max and minimum value on that interval. Okay, but it's got to be a closed interval and it's got to be a continuous function. Okay, I can turn this page. Okay, there we go. All right, on the next page, there's a lot of information there, lots of definitions, and we are going to be talking about those throughout as we go through the other examples. So we're gonna hit what each of these are as we go. Okay. So let's take a look at example 3. It says find the absolute maximum and minimum values of f of x equals x to the 2/3 on the interval -2, 3. So we definitely have a closed interval. Okay. And we're finding the absolute maximum and minimum values of this function, okay? So we need to start by looking for where those max and mins are. And we're gonna do this by hand, by algebraically. So we call that the candidate's test. Okay. We have some candidates that we need to test out here. And so we're gonna have our x values and f of x values. And the two of the points that we need to test for x are the endpoints. The lowest endpoint is a -2, the highest endpoint is a +3. Notice how I left a gap, because there's going to be some in between that I might be able to find and try, okay? So I'm leaving that gap there on purpose. All right, now we're going to, step 2, look for those critical points, okay? So a critical point is a point in that domain where the derivative equals 0 or the derivative does not exist, okay? So we're looking for critical points. So this is either where the inverse equals 0, so the slope is 0, or the derivative of f of x does not exist, okay? So we're looking at those two things. Well, that means we're gonna have to take a derivative of f of x, so let's write it down. We know f of x equals x to the 2/3 power, and we're gonna take a derivative of that, so power rule. So f prime of x equals, drop the exponent in front, so 2/3 x, and then I have to subtract 1, but since it's from a 2/3, it's the same thing as subtracting 3/3, because 3/3 is 1. 2/3 minus 3/3 is -1/3, okay? But that format is funky and looks weird, so I want to take care of that negative exponent and drop it like it's hot. So I'm going to rewrite that as f prime of x equals, I have 2/3, and then the x to the -1/3 gets dropped, so it's the cubed root of x in the denominator there. Okay? All right. Well, how do I find where that equals 0 or to tell if it doesn't exist? Well, there's two things we have to follow here. So I'm going to draw 2 arrows. Okay. First of all, let's set the derivative f of x equal to 0. So we have 2 over 3 cubed root of x set equal to 0. Well, how do we solve that? Might have been a while since you've done this, but that's okay. We all get a little bit rusty sometimes. We haven't done something in a while. When we're trying to get x out of the denominator, we would multiply it to the other side, right? So we would multiply the other side by 3 cubed root of x. But what happens when we multiply by 0? Anything times 0 is 0. So I'm just going to get 2 equals 0, but 2 doesn't equal 0. So I'm running into a problem there, okay? That's because, remember, we can't have x be values that make the denominator equal to 0, because we have a denominator and a variable in that denominator. So there is a restriction. So since there is a restriction, that means that there is a spot on that graph where the derivative does not exist. So that means that f prime of x does not exist. Oops, forgot the d. D and e does not exist when x equals 0, because if x is 0, that's what makes the denominator 0. Okay, so because of that, I can take that back to my candidates test, and I know that a critical point that I need to try is an x value of 0, and that's the only one that I found. Okay. All right, so we're going to try those points. Okay, and so we're going to plug them in. When we plug them in, you plug them into, everybody say, the original. You don't plug it into the derivative, you plug it into the original. So the original was x to the 2/3 power, so that's the same thing as the cubed root of x squared. Okay, so let's plug in -2. -2 squared is 4, so this is the cubed root of 4. We don't need to type that into our calculator. If we plug in a 0, cubed root of 0 is just 0. If we plug in a 3, we'll get the cubed root of 3 squared is 9, okay? And when we think of a cubed root, think of the ones that you know, like the cubed root of 1 is 1. The next perfect cube would be 8. The cubed root of 8 is 2. So since 4 is between 1 and 8, then this one is going to be 1-ish. Okay, we're just estimating. The cubed root of 9, well, do the same thing. The perfect cube below 9 is an 8. The perfect cube above 9 is what? I forget, 27? So 9 is between 8 and 27, and so we know that the cubed root of 8 is 2, so that's the lower end, so this one's going to be 2-ish. Okay, so now to tell which one's an absolute max or min, what do you think that these numbers are going to tell us? Well, the biggest one must be the max, the smallest one must be the min. So the smallest one is 0, so this must be my absolute minimum. The biggest one is when x is 3, so that must be my maximum. Okay, so I'm going to write my answer up here because I'm totally out of room. Hold on, Lucas, let me finish doing this. He's all trying to use sign language or something to tell me something. All right, so let's write our answer up here. So answer. Okay, so the absolute minimum is of 0, absolute minimum of 0, and that is at a value of x equals 0. Y is 0 and x is 0, absolute minimum, okay? And then we have an absolute maximum of, we can just put cubed root of 9 at x equals 3, okay? And that whole thing is my answer, so I'm going to box that whole thing. Okay. Absolute minimum of 0 at x equals 0, and absolute maximum of cubed root of 9 at x equals 3. Okay. So yeah, that problem was a pretty extensive problem. The next one isn't going to be as bad, and if my calculator didn't die, I'm going to show you a really cool trick that I learned on the calculator, and I'm pretty excited about it. So yeah, we don't always get to use calculator, but when we do, we are happy about it. Okay, it says find the absolute minimum and maximum values of y equals 3x cubed minus 12x squared plus 3x plus 1 on the interval -1.5 to 4. So we have a closed interval again, okay, and that's good. And this time we have a polynomial, and we know polynomials are continuous, okay? So this one, when we end up doing the derivative by hand, we're not going to be able to set it equal to 0 and solve. It's messy. It's not going to be pretty. So when that happens, we kind of have to fall back on our calculators because we don't want to make a mistake by trying to do it by hand, what ends up happening is when you take the derivative, it takes this degree down to the second degree, and you would have to use quadratic formula to solve, and that's just a ton of extra work. And in calculus, we don't need to go through all that. We've already been through all that in Math 1, Math 2, Math 3. We've already done there, been there, done that. All right, so here's our candidates test. We know the lowest endpoint is negative 1.5. The highest endpoint is 4. There might be some in between that we have to try, so that's why there's a gap there, okay? So we're looking for the absolute minimum and maximum values. So we need to find those critical points that are in between the endpoints so that we can test them out to make sure that we find the actual absolute max and min, okay? So what we gotta do is in our calculators, we need to set our graph. So we're gonna need to go to the y1 or the y equals button, and we're gonna need to set our y1 to be the function. So 3x cubed minus 12x squared plus 3x plus 1. I'm gonna write down what you need to do first, and then we'll go to the calculator, just because I don't want to leave my calculator on and have it die on us, so because that would be embarrassing. All right, y2 is going to equal the derivative. Okay, so the derivative, we'll just put ddx of y1, x equals x, okay? All right, so let's go to our calculators. See, it's telling me battery's low. Okay, let me clear out everything. Yeah, I already did this. So make sure you clear out everything. All right, so y1 is the original function, so that would be 3x to the third, hit the arrow to bring it back down, minus 12x squared plus 3x plus 1, okay? I learned something new, guys. Go to the equal sign, you know how it's blinking? Hit enter, and then it won't graph that graph. I didn't know that, okay. I don't want it to graph that, I just want to see the derivative graph, okay? So now let's put in the derivative. So I need math 8 ddx of, and let's hit alpha trace y1 so that we can put y1 in there, x equals x, okay? And then we're going to, before we graph it, I want you guys to take note that you also need to change the window. We have an interval that we are on, so we need to make sure that that interval is negative 1.5 to positive 4. So let's change the window. So hit window. Mine's already set there because I just practiced on that example to make sure I knew how to show you guys properly. So I already have it set a low x, negative 1.5, the highest x is 4, and then we can hit graph. So it's just thinking. I could tell it has that little spinning wheel up there by my low battery sign. There it is. Okay, remember, this is the derivative graph. Okay. So remember what we're looking for. We are looking for where the derivative is equal to 0, because that's going to tell us the critical points. So we're basically looking for where it crosses the x-axis at. So look for where it crosses the x-axis. Okay, so I learned how to get those exact points where it crosses the x-axis. So what I need to do is I need to hit trace, and I want to get to that first point where it crosses the x-axis. So I'm going to scroll and scroll and scroll and scroll and scroll. See, I see my little blinking light thing, and I want to pass it up, because from left to right it's going from positive to negative. So I want to be just slightly, oops, where am I going? I just want to be just slightly over 0 there on the positive side. Okay, and then I hit second, calculate, and I want the 0 at that point. So I'm going to hit 2. See how it says left bound? I want to switch to the, I want to hit enter, right bound, and I want to move this to the right because it's going to go below the x-axis. It's going from positive to negative there. So I just want to be, I want to make sure that I'm a little bit on the negative side. So I want to make sure that y value is negative, and then hit enter. And then it says guess, and then hit enter. And it guesses it at x equals 0.131. Okay, so if you need to watch that a couple of times, rewind that and try it again until you make sure that yours matches up with mine. Okay, that's what I had to do when I was learning this. All right, so one of the x values is 0.131. We know that there are two because it's crossing the x-axis twice. So now let's do the same thing over there, but before I do that, I want to draw a graph because I want us to understand what we're looking at here. So just a one-dimensional number line. We know on the graph that it's going from a positive slope to a negative slope. Positive, it hits that point, and then it's a negative slope after that point. Okay? All right, now let's find the other one. So we need to trace and scroll, 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 scroll until we get to the other one. I don't want to hold the button down because every time I do that, it ends up going too far, and then I'm like, it's gone. All right, so because we're going from left to right, I want to be, let's see, I'm above, at a positive y. I want to make sure that I'm at a negative y. I want to be at the one right before I hit the x-axis there, okay? And then I'm going to do the same thing because I'm going from negative to positive. So second, calculate. I want to find the 0, so I'm going to hit 2. And now I want to cross over. I want to make sure that I'm crossed over. Looks like I am right there, 0.14006. And I want to hit, it says left bound, hit. So, sorry, on the left bound, I didn't do it. I didn't want to hit enter yet. I want it to be negative on the left, hit enter. And then on the right bound, I want it to be crossing over, so enter and then guess. And it guesses it to be 2.535. So when I have the point 2.535, it's going from a negative slope to a positive slope because it crosses back over and goes up across the x-axis. Okay? All right, so let's try to understand what that means. That means that at the point 131, the slopes go from positive to negative. So from positive to negative, that means that I have a max there. Okay? It may or may not be the absolute max, but it's a maximum because there could be other maximums, other little humps in the graph. This one goes from negative to positive. So negative slope to positive slope. That tells me that I have a min at this point. It may or may not be the absolute minimum, but it is a minimum. We call that a local minimum of the graph. So the local maximum and local minimum are max and mins of the graph, but they're not the highest high or the lowest low, but they are highs and lows in the graph. Okay. It's easier to explain it that way than to read it out of the definition, right? All right, so let's add these to our table. 0.131 goes first because it's smaller than the 2.535. And we're going to plug those into the function. So I'm going to show you something else that's new in the calculator that, well, it's not new. We know it. It's just we don't think to use it a lot because we're not used to using it. I just think it's really cool. So anyways, we're using our graphing calculator, and I hope you like it. I really do. Okay, so I want to go back to y equals, and remember, we have to plug these back into which function, guys? The OG, the original, okay? So when I go back to my calculator, I want to hit enter on the equal sign on y1 because I want that one to show, but I want the derivative to not show. So I'm going to hit enter on that one and then graph. This is so cool, guys. I'm so excited to show you this. I'm so excited. Okay. So, you know how we would plug it in and, raise x to the third power multiplied by 3 minus 12 times, raise x to the second power, that type of thing? We don't have to do that anymore. We can use our calculator. I love it. All right, so all you have to do is hit second calc, 1 for value, and we're going to type in the x value that we're going to plug in. Let's start with negative 1.5. Make sure you use the negative sign down there. I don't know how many times I keep doing it with the minus sign, but you have to use the negative symbol. All right, hit enter, and it tells you the y value is negative 40.625. Isn't that great? Didn't have to do it by hand at all. Could use our calculator. All right, don't do anything, but just type in the next one, 0.131, and then hit enter. And we get 1.1938. Okay, and then type in the next one, 2.535. Are you guys loving this? I sure am. And I'm getting negative 19.638. And then type in a 4, hit enter, and I get 13. So let's look for the highest and the lowest, and those will be our absolute max and min. Well, the highest y value here is the 13. So that happened to be an endpoint. And the lowest is that negative 40.625. So another endpoint. Now, sometimes they're the endpoints, sometimes it's an endpoint and something in the middle, sometimes it's just points in the middle. We don't know that, so we have to check. So you can't assume that it's going to be the endpoints. And sometimes there's going to be questions that ask you for the extrema, all the extrema, in the relative extrema in a problem. And if you're looking for all extrema, like the relative extrema is everything, then you have to list all the extrema, which would be all of these points would be extrema. These are all max and mins of the graph, okay? All right, so let's write up our answer. You guys ready? We have an absolute max of, it was 13 at x equals 4. We had an absolute min of negative 40.625. At, what was that, x equals negative 1.5. And that's the answer. And that's everything. So your homework assignment, I know it says numbers 1 through 18, but it's actually 11 through 18, 45 and 46. Okay, so that's your homework assignment, and have a good day.